Hi there. So this is now the solution for illustrative problem 10. Determine the inductance per kilometer per phase of this double circuit three-phase line. And the radius is also given. The distance between two conductors are also given. Okay. So we have conductor A, B, C, A prime, B prime, C prime. I just replaced 1.75 by D. So I can simply derive the equation. Radius is also 1.5 centimeters converted to meters. The inductance formula will be like 2 times 10 to the negative 7, the ln of the DEQ or the GMP. In this case, this is DMP, mutual distance between between conductors of the parallel circuit, and then DSP. Please do remember that inductance here is in Henry per meter per phase, and we are asked to get the Henry per kilometer. Okay, now DMP here is equivalent mutual GMD between phases, and DSP is the self GMD of one phase. Now one by one we get DMP and DSP. For DMP, it's the cube root of the distances of each phase conductors. So we have DAB, DBC, and DCA. So how can we get that? For DAB, we will only be considering the A and B conductors, also the A prime and the B prime. So here are they, okay, and the following distances are given as D, 2D, D respectively. Now DAB is given by this equation, DAB, and then AB prime, and DBA prime, then DA prime B prime, raised to 1/4. Okay. Now for DAB, the distance is D. For DAB prime is 4D, BA prime is 2D, and A prime B prime is D. Okay. And finally, we got D times 4th root of 8. So let's just leave it there. Proceed to getting DBC. The same manner as we get DAB. So we list down the involved conductors BC, B prime, C prime with the corresponding distances. The DBC will be like this. I've considered the distance between BC and then CB prime, B prime C prime, and D C B prime. Okay, so raised to 1/4. Okay, for DBC the distance is D, and then 2D, D, and 4D. Okay, and simplified, D and the 4th root of 8 comprise the DBC. Next, for DCA, so we have the arrangements of the conductors. AC, A prime, C prime are considered. The distances are this rather. Now the DCA raised to 1/4 because we have 4 conductors. The following, and this is now their equivalent distances. And DCA is now D times the 4th root of 20. So we now have DAB, DBC, and CA. So we are now ready to get the value of DMP for DCA, AB, and then BC and CA raised to 1/3. And it will give us a value of this. Your D is replaced by 1.75, then 12th root of 1280. DMP is 3.1767 meters. Now we're down to another one variable, which is DSP. For DSP, it's simply cube root of the phases, the distances, self distances, DSA, DSB, DSC. What are they? We get DSA first. So considering only the A and A prime conductors, so we get the self GMDs of these A and A prime conductors. So given 3D as their distance, So DSA is fourth root of A prime self, A to A prime, and A prime to A. And DAA is the R prime, or RE negative 1/4, or 0.7788 R. Also the DA prime A prime, then 3D and 3D. Simplifying and evaluating, we get 0.24765 meters. That's for DSA. Now we're down to DSB and DSC. Look at the configuration. For DSB, we have B prime, and the distance is also 3D. It so happens that for DSC, C prime also has a distance of 3D, which is also the same with DSA. So therefore, but that's for this configuration only. And therefore, the self GMD of these conductors, 0.24765 meters. Now that we have DSB, and DPM or DMP, finally we have now this inductance, although we are asked to find the inductance in Henry per kilometer, so we multiply it here. So we get 0.51032 millihenry per kilometer. That's per phase. Okay, the end.